Hello there, and welcome to Dreamy Science, a quiet corner of the universe where wonder and rest drift together under the stars. Tonight, we'll look upward into the vast and beautiful night sky, a place filled with light, with mystery, and endless whispers from across time. Above us, the moon glows gently. Constellations trace their ancient stories, and the planets shine, familiar, steady companions. But there is always more than what meets the eye. Some of the stars you see tonight have already faded, their light traveling for centuries just to find you now. A faint, hazy cloud in the distance might be an entire galaxy, millions of light years away, and that bright flash of a meteor may be nothing more than a grain of sand burning for a single beautiful heartbeat. The night sky is both ordinary and extraordinary, something we see each day, yet never truly understand. And perhaps that's what makes it so magical. If you find comfort in these quiet journeys, you're welcome to stay a little longer. Leave a small thought, a gentle word, so that another sleepy soul might find their way here too. But for now, you don't need to do anything at all. Just rest. Let your breath slow down. Let your mind drift upward and allow the calm of the night sky to carry you. Let's begin. Every star you see with your naked eye belongs to our own galaxy. When you step outside on a clear night and your eyes adjust to the darkness, the stars scattered across the heavens may feel infinite. Yet every single one of those tiny lights is a neighbor, a shining member of our great Milky Way family. So breathe deeply. The universe is vast, and somehow, you are a part of it all. Astronomers say that under the very best of skies, far from cities, far from noise, the unaided human eye can see about 6,000 stars. 6,000 tiny sparks scattered across the darkness, and yet within our Milky Way alone, there are hundreds of billions more. Countless suns that remain invisible to us, hidden behind distance, dust, and time. Beyond our galaxy lie others, the Andromeda, and faint spirals drifting in the deep. Their stars are far too distant to be seen one by one. Instead, they blur together, soft and ghost-like, forming the pale smudges we glimpse on clear nights. What you see above you is only the faintest sliver of the vast community of suns we live among, a whisper of the universe seen through the narrow keyhole of human vision. Some of those stars are already gone. Their fires have long since faded, and yet their light continues to travel. Every time you look at the night sky, you are peering back in time. Light moves faster than anything we know, but the universe is vast beyond imagining. Even the glow of a nearby star may take years, centuries, to finally reach your eyes. Some of the twinkling lights above you tonight began their journey before the first. Cities were built on Earth. A bright star 100 light years away is showing you its face as it was a century ago. It may no longer look like that at all. Perhaps it has swollen into a red giant, or collapsed in silence, or burst into a supernova long ago, and yet its light keeps racing onward, across the gulf of space, still reaching us, as if nothing has changed. The night sky you see is not a picture of the present, but a moving archive, a living record of what once was. So when you look up tonight, remember, you are not just seeing stars. You are seeing time itself, drifting gently toward you, one beam of light at a time. Each shimmer above us is both here and gone, alive and vanished all at once. Polaris, the North Star, has long been a faithful companion for travelers in the northern sky. It sits almost perfectly above Earth's North Pole, pointing the way home, steady and calm, a light that never seems to move. But even Polaris is not eternal. The Earth itself wobbles gently as it spins, a slow, graceful motion called precession. Over thousands of years, this quiet dance shifts the stars, changing their places in the sky. So the title of North Star has passed from one celestial guide to another. In the age of the ancient Egyptians, it was Thuban, a pale star in the constellation Draco that marked true north and far, far into the future. Around 12,000 years from now, the brilliant Vega will take its turn. This slow rotation of the heavens is a reminder that even the most constant lights are part of a greater rhythm, a cosmic heartbeat that spans the ages. Polaris feels eternal. When we see it tonight, steady and bright, watching over the quiet Earth. But it, too, is only one verse in the long song written across the stars. Long before compasses and satellites, before maps were drawn and oceans charted, the sky was humanity's first guide. Sailors once crossed the vast Pacific by memorizing the rise and fall of constellations. using their patterns to find their way across endless waves. Nomads in distant deserts read the stars like landmarks, orienting themselves by their silent glow. And through all those nights, Polaris waited above the northern horizon, constant, patient, a small, steadfast light reminding travelers where home was. So tonight, as you drift beneath the stars, know that the same light that guided them now shines for you too. A quiet promise written in the sky. In the southern hemisphere, navigators looked to a different guide, the Southern Cross. Entire systems of knowledge grew around the movement of the stars. Polynesian wayfinders, for example, memorized the rising and setting points of hundreds of stars. These patterns were carried not on paper, but in memory, passed down through generations. Their maps were more than tools. They were treasures woven into stories sung into songs, so that they would never be forgotten. When you look up at the night sky, you are seeing the same compass points that once guided caravans across deserts and sailors across oceans, the same stars that watched over explorers long before any compass or satellite ever existed. And stretching across that dark expanse is a soft, glowing band, the Milky Way. On a clear night far from city lights, it looks like a misty river flowing through the heavens. Its light comes from billions of distant stars, their radiance blending together into one continuous shimmer. The reason it forms a band is because we are inside it, peering through the flat, spinning disk of our own galaxy. Imagine standing at the center of a great wheel, looking outward through its rim. That is what we see from Earth. The stars, gas and cosmic dust gather densely along that path, blurring into a luminous haze that arcs from one horizon to the other. In ancient times, different cultures gave it different names. A celestial river, a road of spirits, the backbone of the night. Today, we know it as the plane of our galaxy, our home among the stars. And every faint wisp in that glowing band is another sun, another solar system, another possible world. The Milky Way is both home and horizon, a reminder that we are travelers within the very map we once looked to for guidance. Our galaxy is filled with light we cannot see. Hundreds of billions of unseen suns, each one burning quietly in the dark. The stars you see above tonight are only the faintest hint of what truly fills the Milky Way. Astronomers believe there are between 200 and 400 billion stars in our galaxy. Alone, most are too faint, too distant, or hidden behind veils of cosmic dust to be seen without powerful telescopes. Many are small, cool red dwarfs, humble stars, dimmer than our sun, but so numerous that they make up the great majority of the Milky Way. Others hide within clouds of gas and dust, their light revealed only through the eyes of infrared telescopes, which can pierce the darkness that our eyes cannot. And then, there are worlds with no suns at all, planets that drift freely through the black, untethered, unseen, wandering between the stars. So when you look up and count a few thousand tiny points of light, it's humbling to know that you're seeing only a pinprick of the galaxy's true population, a whisper of the billions that lie beyond. Our galaxy is so rich with suns that no eye, not even across a lifetime, could ever count them all. And yet among all that stillness, there are moments of motion, brief, dazzling streaks that flash across the sky. We call them shooting stars, but they are not stars at all. They are specks of cosmic dust, tiny fragments, sometimes no bigger than a grain of sand, burning brilliantly as they fall through our atmosphere. Moving at tens of thousands of miles per hour, the air in front of them compresses and glows, turning them into trails of fire that vanish almost as quickly as they appear. Most never reach the ground. What we see is their final moment, a farewell spark in the sky. Some come from comets, their ancient trails of dust swept across our orbit year after year. Others are wanderers, random fragments adrift in the solar wind. They are small, but their beauty lies in motion and energy, not size. Each one is a reminder that even the tiniest things in the universe can shine with breathtaking brilliance, if only for a heartbeat. In every streak of light, the universe reminds us, nothing in space is ever truly still. Even the darkness moves, breathing, shifting, alive with unseen motion. From the quietest corners of Earth, far from the hum of cities, the night sky transforms. Most of us live beneath a faded dome, where streetlights, highways, and glowing towers blur the stars away. The heavens we see are only fragments of what once was, But in rare, untouched places, high mountain peaks, lonely islands, silent deserts, the sky awakens. There, the darkness is not empty, but alive. Instead of a handful of bright stars, thousands upon thousands emerge, crowding the heavens in dazzling abundance. The Milky Way stretches wide, a glittering river of light, so bright it can cast shadows on the ground. Through its glow, you can trace the faint smudges of other galaxies, glowing clusters of distant suns and even hints of color, soft blues and pinks of faraway nebulae, painting the sky like breath on glass. Astronomers call these places dark sky sanctuaries, refuges where the night still belongs to the stars. They are growing rarer with each passing year. To stand beneath such a sky is to step back in time, to see the universe as our ancestors once did, raw, vast, and full of wonder. It humbles you, reminding you of your smallness and your belonging. For many around the world, that sight is gone. In crowded cities, the Milky Way has been erased by human light, a ghost hidden behind our own glow. But above the noise, beyond the reach of the lamps, it still waits. A river of stars, flowing endlessly overhead, quietly calling us home. Entire generations are now growing up beneath skies where the stars are gone. The river of light, the Milky Way that once stretched across every night, has vanished for many. Light pollution doesn't just dim the stars, it silences them. It drowns their voices completely, leaving behind only the brightest planets and a few scattered points of light struggling to be seen. Cities that never sleep send their glow upward into the sky. That light scatters through the air, creating a soft, permanent haze, a man-made twilight that never truly fades. And so, in some places on Earth, the Milky Way is gone. Not gone in truth, but hidden. A vast, glittering galaxy still waiting behind the veil of our own making. Astronomers and conservationists are working to protect the remaining dark skies. Not only for science, but for something more fragile, our sense of wonder. To stand beneath a true night sky, to see the Milky Way with your own eyes, is to remember something ancient. It is to feel what every human once felt: connection, belonging, a quiet recognition that we are part of something far greater. The constellations that we know so well, Orion, Ursa Major, Cassiopeia, feel eternal as if they've always been there, unchanging in their watch over us. But even these familiar shapes are not fixed. Each star drifts through the galaxy on its own slow journey, following invisible paths around the heart of the Milky Way. Over thousands of years, their patterns will shift, their outlines will fade, and the skies our descendants see will not be quite the same as ours. The universe moves, quietly, endlessly, even while we sleep beneath it. Because the stars are so impossibly far away, their motions are invisible to us within a single lifetime. To the naked eye, the sky seems eternal, unchanging, constant, familiar. But over tens of thousands of years, the heavens slowly reshape themselves. The familiar outlines we know begin to bend, to drift, to dissolve. Orion's belt, once a perfect line of light, will one day scatter. The Big Dipper will lose its handle, its bowl spilling into the dark. Astronomers can look ahead, simulating the sky of the far future. And the constellations we cherish are almost unrecognizable. The night sky is not a still image. It is a living dance, a slow, graceful shifting of stars through the vast currents of our galaxy. It moves too slowly for us to see, yet it never stops moving. And depending on where you stand on Earth, the dance looks different. In the southern hemisphere, a new sky unfolds, a mirror world to the north. For those who have only known northern stars, traveling south of the equator feels like stepping into another reality after sunset. The Big Dipper disappears below the horizon, its familiar pattern swallowed by the curve of the Earth. In its place, new constellations rise. The Southern Cross, small and radiant, a timeless guide for travelers and sailors. And beyond it, two faint clouds shimmer in the dark, the Magellanic Clouds, small neighboring galaxies orbiting our own Milky Way. Here, constellations take on new forms. The emu in the sky, traced not by stars, but by the dark dust between them, has been known to indigenous Australians for millennia. Nearby strides Centaurus, a celestial guardian watching over the southern night. Each hemisphere tells its own version of the same story, a story written in light, told in silence and always changing. For those who live beneath the southern hemisphere, These constellations feel as familiar and comforting as Orion does to the north. Different patterns, same wonder. Together they remind us that the sky is shared, a single endless canvas seen from many angles. Perspective changes everything. Half of Earth looks upon a view the other half will never see. And still, above us all, the universe stretches further than any horizon we can imagine. If you stand beneath a truly dark sky, far from cities and lights, you might notice a faint mist among the stars, a small, ghostly blur in the direction of Andromeda. Most galaxies lie far beyond the reach of human sight, but this one is close enough to whisper through the darkness. To the naked eye, it seems no more than a smudge, soft and shapeless, like a wisp of fog drifting through space. Yet that haze is another spiral galaxy, a vast island of perhaps 1 trillion suns, spanning over 200,000 light-years. Its light began its journey more than 2 million years ago, long before the first humans ever looked up. Ancient sky watchers saw it too, recording that faint patch of light without knowing what it truly was. They could not have imagined that they were seeing an entire galaxy, filled with worlds beyond number, and even now you can step outside, look up, and see it for yourself, a neighboring galaxy shining softly through time and space. That dim blur is not a single object. It is an ocean of stars, a bridge between galaxies, and a quiet reminder of how much more there is to see. It's an entire island universe, a great spiral adrift in the dark, with suns and planets and mysteries of its own. The faint glow of the Andromeda galaxy began its journey more than 2 million years ago. When you look up and catch that soft blur in the sky, you are not just seeing light, you are witnessing time itself. That glow has crossed the void between galaxies, traveling through silence and shadow for longer than humanity has existed. When that light first left Andromeda, Earth was home to our ancient ancestors, creatures who walked upright, but had not yet learned to speak or dream in words. Entire species have risen and vanished in the time it has taken for that single shimmer to reach your eyes tonight. You are seeing Andromeda as it once was, a snapshot from the deep past, while the galaxy itself has continued to move, to breathe, to form new stars. And in the far future, 4 billion years from now, Andromeda and our Milky Way will drift together and merge, their stars mingling into one vast, radiant galaxy. For now, its ancient light is a messenger from another age, a cosmic time capsule, carrying a story across unimaginable distance. And as you lie beneath the night sky, remember this: some of the stars you see tonight no longer exist. Their light continues to travel on, long after the stars themselves have faded, reminding us that in the universe, nothing truly disappears. It simply becomes light, wandering through time, waiting to be seen. It's easy to believe the stars are eternal, tiny, unchanging fires that have always watched over us. But the truth is far more delicate and far more beautiful. Stars are living things in their own way. They are born, they grow, they burn, and in time they fade. Some end their lives quietly, their light dimming into darkness. Others die in magnificent bursts, supernovae that outshine entire galaxies for a moment, before vanishing into silence. Because light takes time to travel, many of the stars we see tonight are no longer there at all. Their light began its journey ages ago, crossing the gulf of space long before our world even knew cities or stories. Ancient astronomers once recorded bright stars that no longer exist in our skies today. Their notes are whispers from a vanished cosmos. Some of those vanished suns collapsed into dense neutron stars, or disappeared entirely into black holes, their presence now felt only through gravity, their light forever gone. And yet the sky never grows empty. New stars are born from the ashes of old ones, woven from the same cosmic dust that made us. The heavens are alive, a slow, endless cycle of renewal and rebirth. Every glittering point above you is temporary, though its life may stretch for billions of years. And every color tells a story. Cool red stars glowing softly like embers, fierce blue ones blazing with heat and youth. Together they paint the night in quiet fire, a reminder that even in stillness the universe is always moving, always changing, always alive. The colors of the stars are more than decoration. They are messages written in light. A red star glows softly, its warmth gentle and cool by cosmic standards. Some are tiny red dwarfs, burning slowly for trillions of years. Others, vast red giants, swell at the end of their lives, their glow rich and deep, like embers fading in a distant hearth. Blue stars, by contrast, live fiercely. They blaze with heat so intense that their surfaces burn at tens of thousands of degrees. Their lives are short but brilliant, a flash of power that fades quickly into darkness. Our own sun rests somewhere between these extremes, steady, balanced. Its yellow-white light warms the earth and anchors the rhythm of our days. To astronomers, each hue, red, blue, white, is a kind of fingerprint, a signature that reveals a star's temperature, its chemistry, and even how it moves through space. When starlight is split into its rainbow spectrum, it tells a story of what the star is made of, how old it might be, and where it's heading. To the naked eye, the colors are faint, softened by our own atmosphere. But if you learn to look closely, you can see them. The subtle gold of the sun, the icy blue of Sirius, the quiet orange of Betelgeuse. Each color a clue, each shimmer a secret about the universe's burning heart. And then there is the twinkle, that gentle flicker that feels almost magical. But it isn't the star that wavers, it's our sky. As starlight travels through layers of air, it bends and shifts ever so slightly, dancing in the currents of the atmosphere. What we see is the dance, a shimmer born of distance and air, a reminder that even the stillest lights are touched by the breath of our own world. As starlight journeys toward us, it slips through the shifting layers of Earth's atmosphere, currents of warm and cool air, each with its own density, its own motion. And in that passage, the light bends just a little. It drifts, it wavers, its path shimmering with every change of temperature and pressure. To our eyes below, this bending becomes a flicker, a soft pulse of light that seems alive, as though the star itself were breathing. But the truth is quieter still. The star is steady. It's our sky that moves. Planets, closer and broader in our view, rarely twinkle the same way. Their disks of light are larger, their glow less easily disturbed by the restless air. Astronomers call this dance of distortion atmospheric scintillation. It's the reason Earth's telescopes, no matter how powerful, can never see the heavens in perfect stillness. So we climb higher. Observatories crown mountain peaks where the air grows thin and calm, and some telescopes escape the atmosphere entirely, carried into orbit, floating in silence where the sky no longer trembles. From there, beyond the veil of air, the stars no longer twinkle. They shine with flawless steadiness, pure, unwavering, eternal. Astronauts aboard the space station see them as they truly are, clear points of light, unblinking and serene, scattered like jewels across a black ocean. What we see as a sparkle is really the breath of our own world, a reminder that even when we gaze at infinity, we do so through the living air that keeps us here. The difference is striking. From space, the stars no longer shimmer or dance. They shine with perfect precision, each one a steady jewel, suspended in the stillness of a boundless night. Freed from Earth's restless air, their light becomes sharp and pure, unbroken by the flicker of the atmosphere. This is why telescopes like Hubble can reveal such breathtaking detail. Up there, beyond the clouds, they see the universe as it truly is, steady, radiant, and clear. From orbit, the colors of the stars emerge more vividly too. Cool reds, soft golds, fierce blues, their hues shimmer with untouched brilliance. It's a view stripped of distortion, a raw glimpse of the cosmos in its pure form. And yet, as we marvel at that clarity, it's worth remembering that the same atmosphere which blurs our view also shelters us, a thin, living veil that keeps our world warm, breathable, and alive. It protects even as it hides, a gentle distortion between us and the infinite. Deep within those distant stars, the story continues, a story of creation written in fire. Every star is a furnace, a place where the smallest particles of matter are pressed together under unimaginable heat and pressure. For most of its life, a star fuses hydrogen into helium, a quiet, steady rhythm that powers its light. But the most massive among them grow hotter, denser, and more restless. Their hearts ignite new reactions, fusing helium into carbon, oxygen, and heavier elements still. It is in these cores that the ingredients of life are born. Every atom of carbon in your body, every trace of oxygen you breathe, was once forged in the heart of a star. The cosmos builds itself from its own light, and in time, that light becomes us. Every atom of carbon in your body, every breath of oxygen that fills your lungs, was born in the heart of a star. Long ago, those stars burned with impossible heat and light, forging the elements that would one day become oceans, forests, and living beings like us. And when those stars reached their limits, they ended in beauty and violence, collapsing, exploding, scattering their ashes through the dark. Those ashes drifted, gathered, and in time formed new stars, new worlds, new beginnings. The universe is a great cycle of creation, each generation of stars seeding the next, each explosion a promise that nothing truly ends. It only transforms. So when you look up at a blazing blue giant, or a fading red supergiant nearing its end, you are seeing the future being forged, the raw materials of what's still to come. And among all the lights above, one star has captured human wonder for as long as we've looked toward the heavens: Sirius, the dog star, the brightest jewel in the night sky. It burns in the constellation Canis Major, so brilliant it almost seems alive. Its name comes from the Greek word for glowing, and across cultures, it has always lived up to that name. Part of its brilliance is distance. Sirius lies just 9 light-years away, one of our closest stellar neighbors. But much of it is its own power. It shines more than 20 times brighter than our sun, a fierce white flame cutting through the cosmic dark. To the ancient Egyptians, the rising of Sirius marked a sacred time, the flooding of the Nile, the renewal of the land. They called it Sopdet and saw in its return the promise of life. Even now, as you look up and find its steady gleam, you are seeing the same light that guided their seasons, the same star that has whispered through the ages, a constant reminder that we are made of the same fire that fills the sky. Tonight, as winter deepens and the air grows still, Sirius returns to the sky, bright, steady, and unmistakable. Even in cities where the stars are few, its light cuts through the haze, a promise that the universe still watches from above. But Sirius does not travel alone. Circling it, unseen by most eyes, is a faint white dwarf, the dense, quiet core of a long-dead star. Once it blazed as brightly as Sirius itself, but now it glows with a soft, ghostly light, completing its slow orbit every 50 years. Together, they dance. One brilliant, one fading, a cosmic pair bound by gravity and memory. For thousands of years, people have looked up to this light and found meaning in its steady gleam. In ancient Mesopotamia, it was a divine sign. In the Pacific Islands, it guided sailors across vast stretches of ocean, their canoes gliding beneath its watchful glow. To the Egyptians, its annual rising meant the Nile would soon flood, a return of life to the desert, a renewal written in the stars. The Greeks, watching it blaze in summer's heat, called it the dog star and gave us the phrase, the dog days of summer, a time when the world shimmered with both warmth and madness. Across North America, many indigenous peoples wove Sirius into their legends, their stories tracking its path as a signal for migration, harvest, and time itself. Everywhere across centuries and continents, this single point of light became a compass, a clock, a character in the great story of the sky. And yet, Sirius is, at its heart, just a star, a sphere of burning hydrogen and helium, fusing atoms in silence across the void. But somehow, through the eyes that watched it, through the dreams it guided, it became something more, a symbol of endurance, a whisper of the eternal, a reminder that even the smallest spark can light the way through the longest night. Yet its place in human imagination has made Sirius one of the sky's most enduring symbols. But nearby, another wonder rises, a cluster that glimmers like a handful of diamonds scattered across velvet, the Pleiades, sometimes called the Seven Sisters, a tiny swarm of light that dances in the shoulder of Taurus. Even through the glow of city skies you can still see them, 6 or 7 stars to the naked eye, though in truth there are hundreds. Through binoculars or a telescope, they bloom into a shimmering cloud, young, blue suns burning bright and fast, still wrapped in the faint dust of their birth. Their light drifts through those delicate veils, creating the soft, ghostly reflection that makes them appear to glow from within. Across the world, the Pleiades have been known by many names and woven into countless stories. To the Greeks, they were sisters pursued across the heavens. To the Maori, they marked the new year, a time of renewal. In Japan, they are called Subaru, a name that now rides on the front of every car bearing that shining cluster of stars. The Pleiades are close, just 400 light-years away, near enough that their beauty feels almost personal, as though the universe hung them in the sky for us to find our way by their light. Not all wonders are distant or faint. Some, like the Pleiades, linger close enough to stir something ancient in us, a memory of when our ancestors first looked up and named the stars by the warmth of their glow. And below them, in the great hunter's belt, another light begins to shimmer, a soft, hazy glow in Orion's sword, It is the Orion Nebula, a cradle of newborn stars, a nursery where the cosmos still breathes life into the dark. If you trace the constellation of Orion, beneath his famous belt lies a small, delicate line of stars, the Sword. And at its center, if you look closely on a clear, dark night, you'll notice a faint misty patch of light. It's not your eyes playing tricks. That soft glow is the Orion Nebula, one of the brightest and closest stellar nurseries in our galaxy. Through binoculars or a small telescope, that blur becomes alive. Vast swirls of gas and dust lit from within by newborn stars, each one still wrapped in the remnants of the clouds that created them, each one pulsing with new light. Astronomers believe thousands of stars are forming there right now, their energy sculpting the nebula's delicate folds, shaping the luminous mist into patterns of creation. To ancient eyes, it was simply a mysterious smudge, a secret hidden among the stars. But today we know it as something far more profound, a place where stars are born, a reminder that even the heavens have nurseries. The Orion Nebula lies just 300 light-years away, close enough that we can almost imagine its glow spilling softly across the dark. Every time we gaze upon it, we're watching creation in motion, a moment of cosmic birth unfolding across light-years and time. Nebulae like Orion's are the great canvases of the cosmos, colossal clouds of gas and dust that stretch for unimaginable distances. Some shine brightly, their colors ignited by nearby stars. Others are dark and hidden, their forms revealed only when starlight passes through them. They are the breath of galaxies, the places where endings become beginnings, and the ashes of old stars gather once more to spark new ones into life. Ultraviolet light streams out from the hearts of massive suns, spilling across the darkness like invisible fire. When it touches the clouds of gas around them, something magical happens. The atoms inside those clouds begin to glow, each one releasing its own faint color in response. These are the emission nebulae, vast, luminous regions where new stars are born. They paint the heavens with hues of rose and emerald, sapphire and violet, their colors shaped by the elements within. Hydrogen glows a soft, tender pink, as it does in the Orion Nebula, one of the most radiant cradles of creation we can see. To our eyes, these nebulae appear delicate and serene, like wisps of cosmic silk drifting through space. But within them lies a storm, a dance of energy, radiation, and gravity weaving the raw material of stars into being. They are not gentle at all, but cauldrons of creation where light is forged from chaos. Yet not all nebulae create their own glow. Some shine more quietly, borrowing their beauty from nearby stars. These are the reflection nebulae, cosmic mirrors that scatter and soften starlight until it gleams in a tranquil, silvery blue. The light you see from them has no fire of its own. It is a borrowed shimmer, a gentle echo of brilliance from elsewhere. One of the most beloved examples lies near the Pleiades cluster, where young, bright stars illuminate veils of dust that wrap around them like soft smoke. Their faint blue glow is caused by scattered light, the same way our own daytime sky appears blue. Through the telescope's eye, these reflection nebulae seem almost fragile, thin whispers of light suspended in endless night. But to those who watch the stars, they are proof that even in reflection, the universe remembers how to shine. These nebulae are like cosmic mirrors, catching the light of nearby suns and casting it gently back into the dark. They often linger near clusters of young, bright stars, where starlight is plentiful, where radiance spills freely across the void. They don't blaze with the drama of the glowing emission nebulae. Instead, they shimmer softly, like the faint echo of a song long after it's been sung. They are the universe's whispers, delicate reminders that beauty isn't always loud or brilliant. Sometimes it glows quietly, subtle, fragile, and infinitely gentle. But not every wonder of the sky lies in light alone. Many stars you see above, those calm, steady points of brightness, are not single suns at all. They are pairs bound together by gravity, locked in a timeless, celestial dance. These are binary stars, two worlds of fire orbiting a shared center, each tugging on the other's light, their motions perfectly balanced in invisible harmony. Some are equals, twirling together like partners in an endless waltz. Others are unequal, a great massive star guiding a faint, smaller companion through wide, sweeping arcs across the heavens. To our eyes, they appear as one, a single glimmer in the darkness, their closeness concealing their dual nature. But through the lens of a telescope, astronomers can see the truth. Two lights intertwined, bound by gravity, forever circling in the quiet rhythm of eternity. And as we look up at the sky, it's humbling to remember, solitude is rarer than it seems. Even among the stars, companionship is the rule, not the exception. Our sun, for all its warmth and brilliance, may be the exception, not the rule. It drifts through space alone, a solitary flame in an ocean of darkness. But most stars are not so lonely. Across the galaxy, companionship is common. The universe, it seems, loves partnerships. Binary stars, two suns bound together by gravity, remind us that even in the quiet emptiness of space, connection endures. They orbit one another in slow, graceful arcs, their shared gravity holding them together for millions, even billions, of years. It might feel natural to think that every star is like our sun, alone, surrounded by planets, steady in its solitude. But the truth is the opposite. Astronomers now believe that binary and multiple systems may outnumber single stars. In the grand map of the cosmos, loneliness is rare. Togetherness is the norm. Some of these stellar pairs are born together, formed from the same swirling cloud of dust and gas. Siblings, forever linked by gravity's invisible thread. Others meet later, drawn together by chance encounters across light years. Some live in harmony, each star tracing gentle orbits around their common center. But others are turbulent. In the most dramatic unions, a massive star can draw gas from its smaller partner, forming shimmering disks of light and flame. Sometimes, one star dies, collapsing into a white dwarf, a neutron star, or even a black hole, forever changing the balance between them. And yet even then the bond endures. Their dance continues, beautiful, chaotic, and eternal. Among the stars, even destruction can give rise to wonder. And perhaps that is the quiet lesson they teach, that in this vast universe, connection, in all its forms, is what truly endures. For planets orbiting more than one star, life would unfold beneath skies unlike our own. Imagine standing on a distant world as two suns climb the horizon, one golden, one pale, their light spilling across the landscape in overlapping shadows and colors unknown to Earth. At dusk, those same suns would fall in opposite directions, painting the sky in twin sunsets, a slow waltz of fading fire. Night would never come the same way twice. Solitary stars like our sun are special, but perhaps they are not the rule. In the grand story of the galaxy, most stars share their light. Some are paired, some are bound in threes or fours, weaving together in gravity's elegant choreography. In a triple system, two stars may circle closely, their dance intimate and fast, while a third companion drifts farther out, watching from the edge. And in quadruple systems, pairs orbit pairs, a cosmic ballet of light and motion, each step balanced by gravity's patient hand. To our eyes, they may appear as a single point of light, a quiet star in the dark. But through a telescope, their secret is revealed, a miniature galaxy all its own, filled with rhythm and complexity. For any worlds within these systems, the sky would be a living spectacle. Multiple suns rising and setting, shadows twisting in different directions, and colors shifting through every hour. Such places remind us that the universe is endlessly creative, writing its stories not just in stars and worlds, but in the light between them. While our single sun feels so familiar elsewhere, entire solar systems live beneath the glow of several suns at once, their skies awash in shifting colors and overlapping dawns. Each world moves to a different rhythm of light, each orbit tracing a harmony written in gravity. But not all stars shine steadily. Some seem to breathe, their light pulsing gently across the darkness like the slow heartbeat of the universe. These are the Cepheid variables, stars that expand and contract in a perfect rhythm, brightening and dimming over days or weeks. To our eyes, they flicker almost imperceptibly, but to astronomers, they are cosmic beacons, their steady pulse revealing distances beyond imagination. Each cycle of light is a measure of truth, a link between brightness and distance, a way to map the unfathomable depth of space. By listening to their rhythm, scientists learn to measure how far the galaxies truly are. It was as if the universe had begun to whisper its scale, one heartbeat at a time. What began as the curiosity of a star that seemed to inhale and exhale light became one of the greatest discoveries in cosmology, a key that unlocked the size of the cosmos itself. Now, when you look up and see a star twinkle faintly, You might imagine it breathing in time with the slow pulse of creation. A reminder that even in the silence of space, the universe has rhythm and every flicker is part of its song. Each pulsing Cepheid is both a marvel and a measuring stick for the cosmos, a gentle heartbeat that tells us just how vast the universe truly is. For centuries, the size of the universe was an unanswered question. Were the stars scattered close by, like glowing dust in the night? Or were they impossibly far away, their light crossing ages to reach us? Then came the Cepheids, stars that pulse with patient regularity, their rhythm as steady as breath. In the 1920s, astronomer Edwin Hubble looked to the Andromeda Galaxy and found those tiny beacons flickering in its misty glow. By measuring the length of their pulses, he could tell how bright they truly were, and from that, how far away. The answer changed everything. Andromeda wasn't part of our Milky Way at all. It was a whole other galaxy, a distant island of stars adrift in a sea of countless others. In a single discovery, the universe expanded beyond imagination, no longer one shining city of stars, but billions upon billions, each with suns and worlds of their own. And through it all, the Cepheids kept beating softly, their light traveling across space and time, bridging the gulf between our small world and the infinite beyond. Even now, in an age of powerful telescopes and orbiting observatories, these rhythmic stars remain our trusted guides, the quiet metronomes of the cosmos, reminding us that from the simplest of patterns can come the grandest of truths. Not all stars stay small and steady like our sun. Some grow vast and wild as they near the end of their lives. Red supergiants, the titans of the stellar world. They swell to unimaginable sizes, hundreds of times larger than the sun, so immense that if one were placed at the center of our solar system, its glowing surface could reach far beyond the orbit of Mars. Yet for all their size, these stars are fragile. Their outer layers are thin and trembling, lit by a soft red glow that flickers like a dying ember. Deep inside, their cores burn with desperate energy, fusing heavier elements in a final attempt to hold back the pull of gravity. It is a slow surrender, a quiet struggle between creation and collapse. They shine fiercely, but only for a little while longer. To look upon a red supergiant is to witness a star in its last chapter. Swollen, unstable, its brilliance edged with inevitability. Betelgeuse, the bright shoulder of Orion, is one such giant nearing the end. Someday it will fall inward upon itself, its light flaring in one last breathtaking act. A supernova echoing across the galaxy. And then, silence. Only dust, drifting where a sun once lived. Even the grandest stars cannot escape time. They too must fade, their fire giving way to darkness, so that new stars may one day be born from the ashes of their light. High on a cold winter night, the constellation Orion stretches across the sky. At his shoulder burns Betelgeuse, a ruby star, soft and unsteady, glowing like an ember that refuses to go out. For centuries, stargazers have watched it with wonder. Betelgeuse is a red supergiant swollen to hundreds of times the size of our sun. Its light, so deep and warm, comes from the last fires of a dying heart. Inside, the star has already spent the hydrogen that once gave it life. Now it fuses heavier elements layer upon layer, quietly building toward its inevitable end. Sometimes its brightness changes, a slow dimming that ripples through the night sky. In 2019, the fading grew so strong that many wondered if the moment had come, if Betelgeuse was about to explode. But the old star recovered, returning to its usual glow, a reminder that even giants can falter and endure. Still, astronomers know the truth. Betelgeuse lives in its twilight. Whether it lasts another 100,000 years or only a fraction of that, its fate is already written. One day, it will not fade quietly. It will erupt in a final blaze, a supernova. For weeks, maybe months, its light will flood the sky, bright enough to be seen even in daylight, outshining every star, every planet, every moonlit shadow. And then, silence. Its fire will end, leaving behind a cloud of dust and memory, a promise that even in destruction, the universe makes room for something new to begin. Such an event has graced our skies before. Ancient astronomers once watched in awe as unfamiliar stars appeared overnight. Brilliant, ghostly lights born from the death of suns. When Betelgeuse finally collapses, its story will echo theirs. It lies about 600 light-years away, close enough for us to witness its brilliance, yet far enough to bring no harm. In that distant moment, its core will fall in upon itself, compressing matter beyond imagination, while its outer layers are flung into space. A final, magnificent release. From the wreckage, a dense heart may remain, a neutron star, so heavy that a teaspoon of it would weigh as much as a mountain. And the scattered debris will carry precious elements, iron, oxygen, carbon, the very ingredients of planets, of oceans, of us. When it happens, people all across Earth will look up. For nights and nights, the heavens will bloom with a light so brilliant it will outshine every star, perhaps even rival the moon. A single point of radiance, shared by everyone beneath the sky. A reminder that even endings can be breathtakingly beautiful. A supernova is not a quiet death. It is an act of creation disguised as destruction. In the blink of an eye, a star releases more energy than all the other suns in a galaxy combined. Some flare and fade within weeks. Others linger for months, their glow stretching across the dark like a memory refusing to fade. And when the light finally dims, the universe is never quite the same. The dust from that dying star will drift through space, settling into clouds where new stars will one day be born. Because in the grand rhythm of the cosmos, every ending is the beginning of something new, beyond their fleeting brilliance. Supernovae are the great engines of creation. When a star dies, it scatters its riches, carbon, oxygen, iron, gold. The very elements forged in its heart are flung across the void. Those drifting embers will one day gather into new worlds, new oceans, new lives. Without these cosmic explosions, there would be no Earth, no trees, no breath, no us. The light of a supernova may last only a few weeks, but its legacy endures forever. To imagine an entire galaxy dimmed by the death of a single star is to glimpse the astonishing balance between power and impermanence woven into the fabric of the cosmos. One of the most beautiful reminders of this is the Crab Nebula, the ghost of a star that once blazed in our own night sky. In the year 1054, astronomers in ancient China and beyond looked up to see a new light appear, brighter than Venus, visible even in daylight. They did not know they were witnessing the death of a giant. Today, nearly 1,000 years later, that light still echoes across the sky. Through telescopes, we see a delicate web of glowing filaments, a tangled shell of gas and dust, still expanding outward from the explosion. At its heart spins a pulsar, the collapsed core of the original star, rotating with astonishing speed, beaming out pulses of energy like a cosmic lighthouse. The Crab Nebula is a time capsule, a living bridge between the ancient and the infinite. Every flicker of its light connects us to those who first saw it rise, reminding us that even the death of a star can leave behind something eternal. When we look upon the Crab Nebula, we are not just seeing light, we are witnessing memory, the memory of a star's death, and the quiet, enduring heartbeat of what remains. From the ashes of supernovae, some stars are reborn as pulsars, tiny spinning beacons scattered through the darkness. They are the collapsed hearts of giants, compressed so tightly that a single teaspoon of their matter would outweigh a mountain. Though small beyond imagining, they are fierce with motion. Many spin dozens of times each second, their beams of energy sweeping through the void like lighthouses of eternity. Each pulse that reaches us is a whisper of a turning star, its rhythm so steady that it rivals the precision of our finest atomic clocks. Astronomers measure these pulses to chart the distances between stars, to test the laws of gravity and time itself. And still, for all their science, there is poetry in the thought that deep in the silence of space, there are stars that keep time. They do not fade or falter. Their light flickers across centuries, marking the slow, endless rhythm of a living universe. Every pulse, a heartbeat of the cosmos, steady, eternal, and endlessly patient. Out beyond the calm shimmer of familiar stars, in the quiet after a supernova storm, lie the most powerful hearts the universe has ever made. They are called magnetars, the rarest, fiercest kind of neutron stars. At first glance, they seem unremarkable, tiny, no larger than a city. Yet they carry the weight of several suns crushed into a sphere just 20 kilometers wide. But their true power is invisible. Each one is wrapped in a magnetic field so strong it could tear apart atoms, bend the laws of physics, and twist light itself. These fields are trillions of times stronger than Earth's own gentle magnetism. When they shift or snap, they release flares so intense that for a heartbeat they outshine entire galaxies. A silent quake of the cosmos, flashing and fading in an instant. If a magnetar ever wandered close to Earth, its power could shred our planet's magnetic shield. But the universe keeps them at a safe distance. They remain far away, distant and dangerous, Like sleeping dragons in the dark, to astronomers, they are mysteries made real, laboratories of the impossible, where the fabric of reality is stretched to its very limit. And to the rest of us, they are a reminder that even in the deepest silence of space, there are tempests waiting to awaken. Black holes hide in the night sky, their presence known only through whispers of light. You cannot see them, no telescope can. Their gravity is absolute, a pull so fierce that even light itself cannot escape. And so they vanish into perfect darkness, leaving only their influence behind. Around them the universe bends. Stars circle invisible companions, their paths betraying what cannot be seen. Streams of gas spiral inward, heating to millions of degrees as they are drawn toward the point of no return. For a brief moment that falling matter glows, a final cry of light before it disappears forever. To the naked eye, there is nothing there, no shimmer, no color, only absence. Yet, through the watchful eyes of telescopes, astronomers have traced their fingerprints, ripples in starlight, echoes of unseen mass, ghostly X-rays flaring in the dark. Some black holes are the remnants of titans, stars that once burned brighter than 1,000 suns before collapsing under their own weight. Others dwell in the hearts of galaxies, colossal engines of gravity that anchor the spiral arms of worlds. When a black hole feeds, it does not feast quietly. Gas from a nearby star is torn loose, drawn into a glowing disk that spins faster and faster, until friction ignites it into a brilliant, deadly halo. To us it looks like light being born from darkness, a paradox glowing in the void, and when the feeding stops, the light fades once more, leaving only silence. A reminder that some of the universe's most powerful forces live forever unseen, hidden not in shadow, but in gravity itself. As matter falls toward a black hole, it does not vanish quietly. Friction and gravity twist it into motion, spinning faster and faster until it glows with a fierce, invisible light. These swirling disks release torrents of energy, X-rays so powerful they can outshine entire galaxies in that narrow band of the spectrum. To our eyes, they would seem like flickering beacons, brightening and dimming as the flow of matter ebbs and swells. Sometimes the violence is even greater. Jets of gas and plasma erupt from the poles, streaming through space at nearly the speed of light, stretching for thousands of light years. What seems like destruction is also creation, a way for the universe to recycle its matter, to move energy from one form into another. Even in their darkness, black holes help shape the living rhythm of galaxies. At the very heart of our own galaxy, hidden behind clouds of dust and time, lies a giant. Sagittarius A star, a supermassive black hole with the mass of millions of suns. It sits at the Milky Way's center, silent and unseen. Yet every star in our spiral home moves under its gravitational command. We cannot look directly into it, but we can watch the stars that dance around it, whipping through their orbits at unimaginable speeds. Their motion betrays the presence of something vast, something dense beyond comprehension. And then, in 2019, humanity caught its first glimpse of that hidden heart. A ring of fire surrounding a shadow, light bent and twisted by gravity itself, matter glowing in its final moments before falling beyond the event horizon. That image, faint and golden, was more than a photograph. It was a mirror held up to the cosmos, a reminder that even in darkness, there is light struggling to escape, and in silence, there is something profoundly alive. Supermassive black holes like this one are believed to rest at the centers of nearly every galaxy, their gravity and energy quietly shaping how stars form, how gas flows, how galaxies themselves evolve through time. That our own Milky Way is held together by such an invisible force is both humbling and awe-inspiring. It is the silent heart of our home, unseen yet endlessly influential, and beyond it the night deepens. The stars above may seem countless, but they are only the nearest lanterns on an ocean far vaster than we can imagine. Beyond the edges of our galaxy, space blooms with countless others, spirals, clusters and glowing ellipses, each a floating island of light drifting through the cosmic sea. Long ago, the Hubble Space Telescope turned its gaze toward what seemed an empty patch of darkness. For days, it stared into that quiet void, collecting every whisper of light it could find. When the image was revealed, the emptiness dissolved. In that tiny sliver of sky, no larger than a grain of sand held at arm's length, thousands of galaxies appeared, each one filled with billions of stars. Each star with the potential for worlds and, perhaps, eyes looking back at us from another shore of time. The universe, it seems, is not just vast. It is overflowing with creation. Even in the quietest corners, light is waiting to be found. To the naked eye, only a few galaxies reveal themselves, Andromeda, faint and ghostly, and the Magellanic Clouds drifting like silver mist along the southern sky. But with the right tools, the darkness between the stars transforms into something else entirely, an ocean of light stretching forever outward. The night sky is not just a canopy of stars. It is the threshold to a vast and silent universe of galaxies. Through the lens of a telescope, these distant realms take shape, some swirling in perfect spirals, their luminous arms unfurling like ribbons of starlight from a glowing heart. Others are soft and smooth, vast ellipses of ancient suns, their fires dimmed by the passage of time. And then there are the irregulars, fractured, chaotic, sculpted by collisions and rebirth. They are the wanderers of the cosmos, still finding their form in the deep night. Each galaxy tells its own quiet story. The spirals, alive with blue stars and glowing gas, speak of youth and motion and creation. The ellipticals whisper of age, of countless generations of stars that burned, faded, and gave way to calm. The irregulars hum with the energy of change, where gravity still writes its story in the language of chaos and light. Through telescopes, their diversity feels endless. Some blaze brilliantly, others barely shimmer against the void. Yet everyone, no matter how faint or far, is a universe unto itself, filled with worlds, mysteries, and perhaps even dreams looking back at us from across the cosmic sea. To see them is to understand how endlessly inventive the cosmos can be, a vast artist shaping both order and chaos into luminous forms that drift like dreams through the darkness of space. Some galaxies do not travel alone. They move in clusters, bound together by invisible threads of gravity, their paths slowly curving toward one another over millions of years. And when they meet, it is not a violent crash, but a dance, a slow, graceful merging played out across cosmic time. The stars within them rarely collide. They are too far apart. But the clouds of gas and dust, those delicate veils between stars, collide and compress, igniting waves of newborn suns. Gravity tugs at their shapes, stretching them into vast spirals, luminous tails, and shining arcs that sweep across space like brushstrokes of starlight. Over time, two galaxies become one, their histories intertwined, their stars mingling into a single greater whole. Our own Milky Way, spinning quietly in its corner of the cosmos, is destined for such a meeting, a slow embrace with the Andromeda Galaxy. Billions of years from now, the two will merge into a new and massive elliptical realm of light, their ancient stars united beneath a single name. For now, we watch from afar, witnesses to the silent ballet of galaxies, their motions frozen in the stillness of time. Each collision is a reminder that nothing in the universe is truly still. Everything drifts, collides, and changes, even the galaxies themselves. Far in the southern night sky, two soft clouds of light linger near the Milky Way. They look like faint smudges, barely visible to the naked eye, but through a telescope, they awaken, vast worlds of stars and nebulae, alive and restless. They are the large and small Magellanic Clouds, two dwarf galaxies, our Milky Way's quiet companions on its endless journey through space. Their shapes are uneven, distorted by gravity's invisible pull, caught in a slow celestial waltz with the galaxy that holds us all. Inside them, new stars are born. In the heart of the large Magellanic Cloud lies the Tarantula Nebula, a storm of creation where gas and dust ignite into brilliant light. It is one of the most active star-forming regions we know, a cosmic nursery glowing softly in the dark fabric of the southern sky. For those who live beneath those skies, the Magellanic Clouds are familiar friends, woven into ancient stories, guiding travelers, inspiring myth and meaning. For those in the north, they remain hidden, forever below the horizon, a secret corner of the cosmos, whispering only to the southern world. These gentle galaxies remind us that the Milky Way is not alone, but part of a great family, a web of galaxies orbiting, merging, and shaping one another across the vast expanse of time. Star clusters shimmer within them, like families of light bound together by gravity, each one a tiny reflection of the greater bonds that hold the universe itself. Not all stars live alone. Many are born together, cradled in the same clouds of gas and dust, bound by gravity into glittering communities we call star clusters. Some are small, a few hundred stars, young and restless, still carrying the warmth of their birth. Others are immense, containing thousands, even hundreds of thousands of suns, woven tightly together over billions of years. Open clusters like the Pleiades are loose and youthful, their stars still shimmering near their birthplace. Drifting gently through the interstellar dark, they sparkle like jewels scattered across velvet, each one bright and fresh, each one a beginning. Then there are the globular clusters, ancient, spherical gatherings of stars packed so closely that they seem to glow as a single orb of light. Through a telescope, they burst into fields of brilliance, each point of light a sun with its own story, its own orbit, its own quiet history. To gaze upon a cluster is to witness a family of stars still holding together after billions of years, bound by invisible threads of gravity, by the same cosmic forces that shape galaxies and worlds. Globular clusters are among the most breathtaking sights in the night sky. Crowded spheres of starlight, suspended in the dark, like lanterns marking the passage of time. High above, drifting in the quiet reaches of our galaxy, lie ancient gatherings of stars and globular clusters, each one a perfect sphere of light, so densely packed that its stars blur together, like 1,000 fireflies glowing in unison. Within these clusters, hundreds of thousands, sometimes even millions, of suns share a home only a few dozen light-years wide. In their crowded hearts, the stars sit so close that their light seems to melt into one soft golden haze. Most globular clusters live far from the galactic center, circling the Milky Way like distant companions. Our own galaxy holds more than 100 of them, silent travelers, each one older than memory itself. Many are more than 10 billion years old, their stars among the very first ever born. To the naked eye, they appear as faint, fuzzy patches, tiny smudges on the velvet sky. But through a telescope, they unfold into dazzling globes of starlight, glimmering like suspended jewels from the dawn of time. These clusters are fossils of the early universe, survivors from an age when galaxies were only beginning to form. Their beauty lies not just in their shimmer, but in their endurance, their quiet defiance of time. Some of them are nearly as old as the universe itself, over 12 billion years, still holding their shape, still glowing, still whispering the story of creation to anyone who pauses long enough to listen. The stars within those ancient clusters are among the oldest in the cosmos. They carry almost no heavy elements, a reflection of a time before supernovae had seeded the universe with the ingredients for planets, oceans, and life. To study them is to look back into a nearly primordial age, when the first stars kindled their fires against the endless dark. And yet somehow these fragile gatherings have survived. They have drifted at the edges of galaxies for billions upon billions of years, through mergers, collisions, and the slow tides of gravity. Still they remain, shining softly as they did when the universe was young. When you look at one through a telescope, you are not merely seeing stars. You are gazing at relics of creation itself, living witnesses to the birth of everything we know. And while those ancient lights endure, Earth continues its quiet journey around the sun. Each year, at certain times, we cross invisible trails of dust and ice left behind by wandering comets. As these tiny fragments strike our atmosphere, they flare into brief streaks of fire, meteor showers, the sky's delicate handwriting across the dark. Unlike random shooting stars, these showers arrive in rhythm, each one tracing back to a single radiant point. Some nights they fall slowly, soft as whispers. Other nights they come in glittering torrents, as if the heavens themselves were remembering something long forgotten. Among all the celestial displays, a few return with comforting regularity: the Perseids, the Geminids, and the Leonids. Each is tied to a wandering parent, a comet or an ancient asteroid that shed its dust long ago. And each year, as Earth drifts through those invisible trails, the sky awakens with falling light. They come on schedule, faithful as the seasons, etching silver lines across the dark. Though each meteor is no larger than a grain of sand, their fiery passage reminds us that we live in motion, our planet forever sweeping through a living solar system, woven with the remnants of ancient travelers. Every August, the Perseids return. Their origin lies in the wake of Comet Swift-Tuttle, a giant that circles the sun once every 133 years. As Earth passes through its debris, the dust and ice ignite in our atmosphere, flaring into brief luminous arcs. On clear nights beneath dark skies, you may see dozens in a single hour, bright, quick, and graceful, some leaving ghostly trails that drift and fade, as if the sky itself were still dreaming. To lie beneath the Perseids is to feel time slow and widen. Each streak is a memory of a comet's passage, a whisper from the deep past burning away in a heartbeat. And yet, for that instant, the universe feels close enough to touch. The Perseids take their name from the constellation Perseus, for it is there, just above the northern horizon, that their trails seem to begin. Each summer, when the air grows still and the nights stretch long, the Perseids return like a familiar song in the sky. For centuries, people have watched them. Farmers, sailors, poets, and dreamers, all lifting their eyes to trace those fleeting lines of light. They wove stories into their glow, calling them gifts from the heavens or messages written in fire. Even now, they remain a favorite of stargazers, a perfect blend of predictability and wonder. Each meteor is only a speck, a fragment of an ancient comet meeting Earth's atmosphere in a final, brief blaze. Yet for that instant, the whole universe seems to breathe with us. Meteor showers are not new to history. Long before telescopes or modern science, people recorded the falling stars. Ancient Chinese, Korean, and European texts speak of nights when the heavens seemed to unravel, when countless streaks filled the darkness until even the bravest stood silent beneath them. In those times, such displays were seen as omens, warnings or blessings written across the sky. One night in November of 1833, the Leonid meteor storm set the world alight. Witnesses described thousands upon thousands of meteors raining down in waves of fire. Entire towns awoke to the sight, and many believed the end of the world had come. But for astronomers, those records became something more than stories. They were clues, evidence of a cosmic rhythm, proof that even chaos follows a pattern when seen through the eyes of time. Through the ages, those falling lights have guided more than dreams. They've helped astronomers trace the invisible paths of comets, the slow drift of dust through time. By comparing ancient records with modern eyes on the sky, scientists can see how debris streams evolve, how trails of particles stretch and shift over centuries of silent motion. What was once feared as fire from the heavens is now understood as rhythm, a celestial heartbeat repeating in the dark. And still the wonder lingers. Even knowing the science, no one can watch a meteor fall without feeling the same quiet awe our ancestors must have felt. The Geminids are a mystery of their own, a shower not born of ice, but of stone. Most meteor showers spring from the dusty tails of comets, fragile wanderers that melt as they near the sun. But the Geminids come from something stranger, something tougher. Their parent body is an asteroid, a compact rocky relic that behaves like a burned-out comet, its surface scarred and brittle. As it draws close to the sun each year, this asteroid, called Phaethon, sheds grains of dust, each one destined to cross Earth's path in December. And when those ancient fragments rush into our atmosphere, they ignite, tiny sparks of stone becoming stars for a heartbeat, lighting the winter sky with the brilliance of the Geminids. Unlike most meteor showers, the Geminids are not just bright, they are alive with color. Flashes of white, yellow, even green streak across the winter sky like brushstrokes from a cosmic painter. On their best nights, hundreds can be seen, each one tracing a brief glowing arc before fading into the dark. They come from an object that is neither truly a comet nor quite an asteroid, a wanderer caught between worlds. A reminder that the universe rarely obeys the boxes we build for it. And then, there are the fireballs. Most shooting stars vanish in an instant, a whisper of light, gone before your wish can form. But sometimes, one arrives brighter than all the rest, a single spark that swells into brilliance, casting faint shadows on the ground as though the night itself were breathing light. These are fireballs, born from larger fragments of stone or metal, striking the atmosphere at breathtaking speed. They flare and flicker, sometimes bursting apart in silence, each fragment glowing as it falls, a cascade of stars unmade. For a moment, the sky holds its breath, and then the dark returns, quiet and eternal, as if nothing had happened at all. For as long as there have been eyes to see, fireballs have startled the world, sparks of heaven that set hearts racing and stories in motion. They inspire both awe and fear, reminding us how much power can sleep inside even the smallest stones drifting through space. And sometimes, one burns too brightly to stay silent. A bolide, a fireball taken to its extreme, does not simply streak across the sky. It detonates, a flash so bright it rivals the sun, a sound that rolls like distant thunder. For a heartbeat, night turns to day. When the Chelyabinsk meteor fell over Russia in 2013, windows shattered, buildings trembled, and people ran into the streets to watch the heavens unfold in fire. It was a modern echo of something humans have witnessed for millennia. Ancient chronicles speak of skies ablaze, of booms that shook the earth, testimonies of these cosmic visitors arriving unannounced. Bolides are born when larger meteoroids, sometimes as wide as a room, strike our atmosphere at unimaginable speed. The pressure builds, the air compresses, and in an instant the rock explodes, releasing all its stored energy in a single blinding breath. They are rare, but they remind us that Earth drifts through a cosmic storm, a quiet shooting gallery of ancient debris. Most grains of dust burn away unseen, but once in a while, the universe sends us a spark so bright it makes the whole world look up. Every night, whether we notice it or not, Earth moves through a quiet rain of light. Tiny meteors, grains of dust no larger than sand, fall endlessly into our atmosphere. They arrive without warning, burning up in an instant, too faint for most eyes to ever see. Even when no meteor shower graces the sky, the planet is still sweeping through streams of ancient debris, remnants of comets, asteroids, and forgotten collisions from long ago. Astronomers tell us that over 100 tons of cosmic dust fall to Earth every single day. 100 tons of stardust, gently brushing the edges of our world. Most of it passes unseen, each grain a tiny spark that vanishes before anyone can wish upon it. But now and then, a larger piece flares brightly, streaking across the heavens in a brief, brilliant farewell. To look up at the stars is to remember that the sky is never still, that the universe is always arriving, falling softly upon us grain by glowing grain, and sometimes, a meteor's light lingers, leaving behind a faint, ghostly trail that hangs in the air like smoke. These are called trains, luminous veils woven into the night, fading slowly as the stars continue their watch. Sometimes when a meteor moves fast enough, it leaves behind more than just a fleeting spark. As it burns through the upper atmosphere, it ionizes the air itself, turning the thin gases into a ribbon of glowing particles. This is a meteor train, a delicate afterimage that lingers in the dark. For a few precious minutes it may shimmer and curl, shaped by high-altitude winds that twist it into ghostly patterns. Sometimes it looks like a wisp of smoke, but unlike smoke, it glows softly with its own quiet light, the last whisper of something that came from beyond our world. Astronomers study these ethereal trails to understand both the meteors themselves and the restless winds at the edge of space. But for those who simply stand beneath the night sky, they are pure magic, a signature written across the heavens, a fleeting reminder of something passing from one world to another, fading slowly, as if reluctant to let go. And when the trails fade and the sky grows still again, the moon remains, our closest and brightest companion. For as long as humans have looked upward, it has been there, a silent guardian of the night. It floats far closer than any star, a mere 238,000 miles away, and yet it feels infinite in its moods and forms. Its light is borrowed from the sun, but its presence is entirely its own, waxing and waning, guiding tides, seasons, and dreams alike. No other object commands the heavens so completely. The moon has guided travelers, inspired poets, and marked the rhythm of time itself. It watches as we sleep, its silver glow brushing softly against the world below, a reminder that even in darkness, we are never alone beneath the sky. The moon's gravity reaches across the vast distance between us, pulling softly at our oceans, drawing them back and forth in a timeless rhythm. It is this invisible tug that shapes the tides, that breathes life into the shorelines, and keeps the great waters of Earth forever in motion. Unlike the wandering planets, or the brief glimmers of comets that pass and fade, the moon is constant, rising and setting with a quiet grace, a familiar face above the horizon. To look upon it is to share a view that every human in history has known. The same light, the same curve, the same silvery calm. Long before calendars and clocks, before even language or carved stone, people looked to the moon to count the passing of days. Its changing face, from a delicate crescent to a round, glowing fullness and back again, traced a cycle of 29.5 days. That rhythm became our first measure of time. The moon marked the seasons of planting and harvest, guided rituals of renewal, and offered a sense of order to lives ruled by nature. Even today, lunar calendars endure, woven into traditions and celebrations around the world. Our very word month is born from moon, a quiet echo of that ancient connection. Night after night, as it waxes and wanes, the moon reminds us that change need not be sudden. It can be gentle, predictable, something to watch and trust. A light returning just as it always has. And sometimes when the geometry of Earth, Moon, and Sun aligns just right, a shadow begins to creep across its face. Slowly, the bright disk dims, turning to a deep, burnished copper. This is a lunar eclipse, a celestial breath hold. When the moon passes into Earth's shadow and glows like an ember suspended in the dark. Instead of vanishing into the darkness, the moon takes on a deep, coppery glow. This is a lunar eclipse, a quiet transformation that turns the familiar into the strange. The moon does not disappear entirely because Earth's atmosphere bends the sunlight, filtering out the bluer shades and letting the longer, redder light slip through. From the moon's perspective, Earth would appear as a black disk, framed by a ring of fiery sunsets hugging its edges. That crimson light bathes the lunar surface, returning to us as the haunting, blood-red moon. To witness it from Earth is to see the moon both familiar and alien, hanging in the night sky, yet transformed, shadowed, glowing, mysterious. The spectacle unfolds slowly, lasting hours, allowing everyone beneath the night side of the planet to share the same vision, linked by the sky above. For centuries, humans have been captivated and sometimes unsettled by the blood moon. Ancient cultures read meaning into its strange red glow. The Inca imagined a jaguar leaping across the sky, clawing at the moon and staining it with blood. In Mesopotamia, eclipses were seen as omens, signals of danger for kings, prompting rituals to protect the rulers from harm. Some Native American traditions spoke of the moon being consumed or wounded, sparking chants and ceremonies meant to restore it. Across the world, the blood-red moon was read as a celestial omen, warning of war, famine, or profound change, yet not all cultures feared it. Some saw the eclipse as a moment of renewal, a balancing act in the cosmic dance. Today, science explains the cause, but the sight still carries a primal weight. Watching the moon blush red in the night sky feels timeless, a direct link to the awe felt by generations long before us. A total lunar eclipse is a slow, lingering spectacle. Unlike a solar eclipse, which flashes and is gone, the moon drifts gently into Earth's shadow, darkening gradually before taking on its coppery glow. Once fully immersed, the total phase can last over an hour, sometimes approaching 2, its face dimmed yet still luminous. Everyone on the night side of the planet can witness it. No telescope is required and only a clear sky. Ancient peoples gathered beneath it, weaving stories of gods, spirits, and omens. Today, families, stargazers, and astronomers continue the tradition, marveling at a spectacle that is both simple and profound, a shared moment across time and space. As the moon finally drifts free of Earth's shadow, its familiar silver light returns, and the world feels restored. The slow unfolding of a lunar eclipse makes it one of the most meditative shows in the heavens. But when eclipses sweep across Earth in the form of a solar eclipse, the effect is startlingly dramatic. As the moon slips directly between Earth and the sun, it casts a racing shadow across the land. This shadow is not still. It streaks from west to east at speeds faster than sound. From orbit, astronauts witness it as a dark, moving circle gliding across oceans and continents. On the ground, the approach is unmistakable. Light dims, the air chills, and an uncanny silence blankets the landscape. Within minutes, day becomes twilight. Only those standing within the narrow path of totality experience the full eclipse, a fleeting window when the sun disappears behind the moon. Ancient peoples must have felt awe, or fear, as darkness rushed toward them. Today, many travel thousands of miles to stand in that shadow, to witness the rare and precise geometry of 3 celestial bodies in alignment. During totality, the familiar transforms. Stars emerge in the daytime sky, faint but unmistakable, and planets may reveal themselves to the naked eye. Birds fall silent, flowers fold, and the horizon glows with a 360-degree twilight. It is a moment of cosmic poetry, a fleeting reminder of the delicate, intricate dance that governs the heavens. For a few minutes, the sun's blazing light is blocked entirely by the moon, and a strange twilight descends in the middle of the day. In that surreal light, stars emerge, unexpected and unwavering. Venus often shines first, radiant and unmissable, followed by bright stars like Sirius or Regulus. Sometimes even Mercury can be spotted, a hidden jewel revealed only in this fleeting darkness. The world grows hushed. Birds settle into roosts. Insects begin their nighttime chorus. The air feels cooler, heavy with anticipation. Above, the sun's corona stretches outward, a delicate crown of shimmering plasma, usually hidden by the overwhelming brilliance of day. To see stars burn in the afternoon sky is startling, a reminder that the universe is always there, patiently shining, even when we cannot see it. For those few minutes of totality, time seems suspended, hovering between day and night, the familiar and the strange intertwined. Even without telescopes or clocks, ancient astronomers could predict eclipses with remarkable accuracy. They observed the heavens with careful devotion, noticing that these shadows followed repeating rhythms rather than chance. The Babylonians discovered the Saros cycle, a pattern of roughly 18 years that enabled them to forecast eclipses centuries in advance. In China, royal astronomers recorded each eclipse as an omen, linking celestial patterns to the fate of emperors and nations. The Maya aligned their great temples with the sun and moon, constructing calendars that captured these movements with astonishing precision. Across continents and centuries, humanity has watched the delicate choreography of the sun and moon, learning to anticipate the rare moments when the cosmos itself casts a shadow upon the Earth. Eclipses are reminders that the universe is both predictable and awe-inspiring, a dance of immense forces that we can glimpse for a brief, breathtaking instant. To stand beneath a darkened sun and know it would return must have felt like holding a secret power, proof that even the heavens follow a quiet order. Those early watchers of the skies, who carefully charted every rise and fall of the stars, turned mystery into pattern and fear into a reverent understanding of the cosmos's gentle rhythm. Look up tonight, and you may see Venus. It shines so brightly, it can cast shadows beneath the quiet moonlight. Venus is no ordinary star, often the first to appear in the evening, the last to fade at dawn, a steady lantern in the vast dark. Its brilliance comes from thick, reflective clouds that bounce sunlight back into space, lighting the night with a serene intensity. To ancient eyes, Venus seemed twofold, the morning star rising before dawn, and the evening star glowing after sunset. Only later did we learn it was the same luminous traveler, revealed in phases by Galileo's telescope, turning our wonder into quiet knowledge. Today we know Venus hides a harsh and hostile world, where heat and pressure crush all in their path. Yet from our small blue home, it glows serenely, a radiant beacon casting faint shadows, a gentle reminder of the universe's quiet power. And there, not far from Venus, Jupiter gleams steadily, the monarch of the planets, immense and commanding, outshining nearly every star in the sky. Its presence is both humbling and comforting, a steadfast guardian watching over the night. To the naked eye, Jupiter shines as a steady, unwavering point of light, brighter than almost every star scattered across the night sky. Unlike stars, which twinkle and shimmer through Earth's atmosphere, Jupiter glows with a calm, constant brilliance, anchoring the constellations with quiet authority. Ancient cultures revered it, associating its steady light with gods of thunder, power, and rulership. Yet beneath that serene glow, Jupiter is a world of swirling turmoil. Storms stretch across its colorful bands, and the Great Red Spot, a storm larger than Earth itself, has raged for centuries. When Jupiter rises into the night, its presence is undeniable. It draws the eye and holds it gently, inviting you to follow its slow, majestic path across the sky. To watch Jupiter is to witness a giant in motion, orbiting far beyond our world yet visible with startling clarity. Every gleam overhead whispers of the vast scale of our solar system, where even a faint light hints at unimaginable immensity. With binoculars, a quiet miracle appears. Tiny jewels hover beside Jupiter, its largest moons. A simple, magical view, just a pair of steady hands and a small instrument. 4 small lights dance beside the giant planet, Io, Europa, Ganymede, and Callisto. Discovered by Galileo in 1610, they forever changed our understanding of the heavens, showing that not everything revolves around Earth. To the patient eye, they appear as delicate points of light, aligned in shifting patterns night after night, a gentle, ever-changing celestial dance that reminds us how vast and how beautiful the universe truly is. Yet each of Jupiter's moons is a world in its own right. Ganymede is larger than Mercury, a silent giant drifting through space. Europa hides a secret ocean beneath its icy crust, perhaps a place where life quietly stirs. Io is alive with constant volcanic eruptions, its surface ever-changing and restless. Callisto is scarred with craters older than any human record, a frozen witness to the solar system's long history. Watching them drift around their giant planet is to witness motion on a cosmic scale, proof that other worlds orbit far beyond our own. Even today, their quiet, eternal dance feels revolutionary, as it did 4 centuries ago. And then, there is Saturn. Its rings can be glimpsed even through a small telescope. Saturn is a planet of quiet beauty, golden and steady in the night sky. To the naked eye, it is lovely, but through a small telescope, it transforms. Suddenly, a delicate world appears, encircled by shimmering rings, impossible, ethereal, and unlike anything else. The rings stretch for hundreds of thousands of kilometers, yet they are so thin they almost vanish when viewed head-on. They are made of icy fragments, some as tiny as dust, others as large as mountains, all orbiting together in luminous, shimmering bands. Galileo was the first to glimpse them, though his telescope was too crude to reveal their true nature. Centuries later, Saturn and its rings remain a favorite, capturing the imagination of anyone who lifts their eyes to the night. These rings are not eternal. They are slowly crumbling, showering icy particles into Saturn's atmosphere. In 100 million years they may be gone, but for now, they remain one of the sky's most exquisite spectacles, a delicate shimmer suspended in the darkness. Mars sometimes glows brighter than Jupiter, casting a ruddy light across the night. Usually it hangs modestly among the stars, a small red ember quietly pulsing in the heavens. Yet every 26 months, Earth and Mars line up in perfect opposition. The red planet drifts closest to us, suddenly outshining all but Venus, sometimes even Jupiter, its light glowing fierce, steady, and mesmerizing. Ancient observers saw this fiery gleam as a symbol of war and blood, naming it after gods of battle. Through modern telescopes, we see even more. Ice caps glinting in the polar regions, dust storms slowly shifting, and valleys carved long ago by ancient rivers. During these oppositions, Mars commands the sky bright enough to capture the gaze of anyone looking up, and then slowly it retreats, fading back into the vast canvas of stars. Its brilliance comes and goes in cycles, a heartbeat between two planets sharing a cosmic neighborhood. Each close approach renews our fascination, a quiet invitation to look across the void at a world both alien and strangely familiar, waiting patiently for us to return. Mercury, by contrast, is a world of secrecy. Always hugging close to the sun, it rarely climbs high enough to be seen easily. Most people never glimpse it at all, though it appears a few times each year, quietly shimmering, hiding in plain sight near the bright horizon, a fleeting spark for those who know where to look. Mercury rises briefly before dawn, or sets just after sunset, shining faintly near the horizon before slipping back into sunlight. To ancient eyes, it was a quick wanderer, darting across the heavens with unusual speed. So elusive was its path that some cultures believed its morning and evening appearances were two entirely different planets. When Galileo's telescope revealed its phases, like those of Venus and the Moon, it became clear Mercury orbited the Sun. Today, it remains a challenge for patient observers, rewarding those who search for it during its moments of greatest elongation. To find Mercury is to glimpse a hidden treasure, a fleeting ember lingering at the edge of daylight. Quick, delicate, and precious. Farther out, Uranus and Neptune lie in quiet solitude, at the very edge of what we can see from Earth. The solar system stretches beyond the ancients' imagination, into realms where faint worlds circle silently. Uranus, a pale greenish dot, is just bright enough to be glimpsed from the darkest skies, though few recognize it. Neptune is fainter still, invisible without optical aid. These distant giants were discovered by modern astronomy. Uranus in 1781 by William Herschel, Neptune in 1846, its position predicted by mathematics before it was ever seen. Through a telescope, Uranus appears calm and serene, while Neptune reveals stormy bands of deep, mysterious blue. Not all worlds reveal themselves easily, hidden in the dark, faint and slow-moving. They are silent sentinels on the outskirts of our planetary family, waiting patiently for curious eyes to find them. Every so often, comets streak across the night sky, their glowing tails trailing like whispers of ancient light, a reminder that even in the quiet, vast darkness, the cosmos is alive with movement and surprise. Every so often, a visitor drifts inward from the far reaches of the solar system. A comet made of ice and dust slowly ventures toward the sun. As it warms, gas and particles stream outward, forming a glowing coma and tails that can stretch for millions of kilometers. These delicate tails always point away from the sun, shaped by the gentle push of solar wind and light. Some comets become dazzling, dominating the sky for weeks on end. Hale-Bopp in 1997 and Neowise in 2020 captivated millions, drawing eyes upward in quiet wonder. Others are faint whispers, seen only through the lens of a telescope. Comets have always stirred awe, appearing suddenly and vanishing without warning. Unlike the steady planets and stars, they are fragments from the deep, icy archives of the solar system, messengers carrying secrets of creation. To watch one sweep across the night sky is to witness something both ephemeral and timeless. Some return only after thousands of years, moving along elongated orbits. Some circling the sun in mere years, others taking millennia. The long-period comets may appear just once in recorded history, then vanish into the void until distant future generations catch a glimpse of them again, a fleeting spark from the edge of our cosmic home. Some comets travel far beyond Pluto, into the Oort cloud, a vast, unseen reservoir of icy bodies at the edge of the solar system. When gravity nudges one inward, its journey begins measured not in lifetimes, but in the span of civilizations. By the time it returns, languages may have changed. Empires may have risen and fallen, and the world itself may look very different. Imagine an ancient sky watcher, recording a comet thousands of years ago, never knowing that the same visitor would blaze across the sky again in our time. These long-period comets connect us across history, their rare returns stitching together the stories of countless human eyes turned skyward, from one generation to the next. Among these travelers, one is legendary, Halley's Comet. Bright, reliable, and well-documented, it returns roughly every 76 years. Its appearances are woven into human history. Chinese astronomers observed it in ancient times. It was depicted in the Bayeux Tapestry in 1066, seen as a portent of conquest. Mark Twain was born as it arrived in 1835 and passed away during its return in 1910, famously predicting this cosmic coincidence. Halley's path takes it deep into the inner solar system, where sunlight ignites its icy surface, transforming it into a brilliant, fleeting jewel that reminds us of the enduring rhythm of the cosmos and our small yet curious place within it. Generations pass between its visits, making it a quiet, celestial link between grandparents and grandchildren, a gentle reminder of how brief human lifetimes are compared to the slow, steady rhythms of the cosmos. The next time Halley's Comet graces our skies will be in 2061, and once again, it will remind us of the continuity of time stretching far beyond any single life. For centuries, comets inspired fear. Before science revealed their nature, these wandering lights struck awe and dread into human hearts. Unlike the steady stars or familiar planets, they appeared suddenly, blazing across the heavens without warning. To ancient peoples, their unpredictable presence was a sign of upheaval, wars, plagues, or the deaths of kings. The Chinese kept meticulous records, interpreting each as a heavenly signal. In Europe, they were dreaded as hairy stars, portents of fire and blood. Even into the Renaissance, comets carried reputations as harbingers of catastrophe. Only in the 17th century did astronomers like Edmund Halley begin to understand them as natural phenomena, icy wanderers tracing predictable paths through space. Today, comets inspire wonder rather than fear, but the weight of history remains. To imagine a medieval villager gazing at a blazing comet is to feel the raw awe these visitors once provoked. Not gentle beauty, but a mysterious message from the dark beyond. Some comets do not survive their journey toward the sun. They are fragile travelers, made of ice and dust, loosely held together, remnants from the earliest days of the solar system. Sometimes heat cracks their icy bodies and they break apart before our eyes. In 1994, comet Shoemaker Levy 9 shattered, its fragments colliding spectacularly with Jupiter, each impact leaving scars larger than Earth itself. More recently, comet Ison, once predicted to dazzle in 2013, disintegrated as it passed near the sun, leaving only a faint trace in the sky. Watching a comet crumble reminds us of their delicate nature. They can flare brilliantly, then vanish forever, undone by the very star that reveals them. Yet in their dramatic endings, they teach astronomers about their composition, unlocking secrets from the dawn of planetary formation. In their fiery deaths, comets remind us how fragile the building blocks of worlds can be. Far to the north and south, the night sky sometimes glows in another way. Auroras drape the heavens in shimmering curtains of light, green, purple, and crimson rippling as if painted by invisible hands. These are the northern and southern lights, formed when charged particles from the sun stream toward Earth, colliding with our atmosphere and energizing atoms to glow. Each color comes from a different gas. Oxygen paints the sky green and red, while nitrogen glows in shades of blue and purple. A quiet, living dance above our heads, painting the night with ethereal beauty. For those who witness them, auroras feel alive, moving and pulsing with an otherworldly rhythm. For millennia, they inspired myths, spirits dancing across the sky, ancestors speaking, or battles waged in luminous clouds. Even with scientific understanding, their beauty remains. To stand beneath an aurora is to feel the planet itself, connected directly to the sun above, written in light across the canvas of night. These lights begin far from Earth, in the furnace of the sun. Solar flares and coronal mass ejections hurl streams of charged particles into space. Some of these travelers reach Earth, guided by our magnetic field toward the poles. There, they strike the upper atmosphere, colliding with atoms of oxygen and nitrogen. Those atoms absorb the energy, then release it as shimmering light, dancing across the polar skies in curtains of green, purple, and crimson. The process is invisible from space, but breathtaking from the ground. Stronger solar storms make the lights more vibrant, stretching them farther from the poles, sometimes as far south as the Mediterranean or the southern United States. Each aurora is unique, shaped by the strength and direction of solar winds. To witness one is to watch Earth's shield at work, transforming invisible solar fury into beauty, turning violence into luminous serenity, and reminding us that even in the cosmos, chaos can become wonder. In the far north, auroras can appear almost nightly. For those who live in the high latitudes, they are not rare miracles, but familiar companions. In Alaska, northern Canada, Scandinavia, and Siberia, the auroral oval arcs across the sky, and during long winter nights, the lights may appear several times a week, sometimes almost nightly. Locals grow up accustomed to their glow, stepping outside on cold evenings to watch the horizon pulse with green or curtains ripple gracefully above. Tourists travel great distances in hope of glimpsing them, waiting in icy darkness for hours, their patience rewarded by nature's silent performance. The aurora's regularity in these regions is a gift of geography. Earth's magnetic field funnels solar particles into these skies more often than anywhere else. Yet even for those who see them frequently, auroras never lose their wonder. They are both predictable and unpredictable, familiar yet never quite the same. Each night, the sky is painted anew by the invisible hand of the solar wind. Auroras are not unique to Earth. Other planets with magnetic fields host these shimmering curtains of light as well. Jupiter's auroras are enormous, powered not only by the solar wind, but also by its volcanic moon Io, which spews material into space, feeding the giant planet's glowing eternal light show. Some auroras are larger than Earth itself, glowing in ultraviolet light, invisible to human eyes. Saturn has its own auroras, tracing graceful arcs across its poles, while Uranus and Neptune display shimmering curtains shaped by their tilted magnetic fields. Mars, with only remnants of a magnetic field, hosts patchy auroras in localized regions. Studying these lights across the solar system reveals how planets interact with both their star and their own magnetic environments. It reminds us that auroras are not unique to Earth. They are cosmic phenomena, written wherever winds of charged particles meet magnetic fields. What we see as beauty is, in fact, a universal signature of energy. Long before calendars existed, humans looked to the stars for guidance. The zodiac constellations became a celestial calendar, 12 constellations tracing the sun's path across the sky. Farmers noticed patterns. When certain stars rose at dawn or set at dusk, the seasons were shifting. The rise of Virgo or Taurus might signal planting, while Scorpio's return marked the harvest. This practical knowledge helped civilizations thrive, tying human survival to the quiet motions of the heavens. Over time, the zodiac became more than a calendar. It evolved into astrology, with constellations linked to personalities and fate. Yet its roots were practical, born from the need to measure time and anticipate the cycles of the Earth. Today, the zodiac remains familiar, though its stars have shifted slightly due to the slow wobble of Earth's axis. Its constellations remind us of the deep bond between human life and the rhythms of the cosmos. The ecliptic marks the sun's yearly path through the constellations. If you watch the sun from the same spot every day, you will notice it does not wander randomly through the heavens. Instead, it follows a steady, graceful path, tracing a great circle across the sky over the course of a year. Along this path, the sun appears to move from constellation to constellation, quietly guiding the changing seasons. The moon and the planets stay close to this line as well, their orbits aligned with Earth's. For ancient sky watchers, the ecliptic was more than a pattern. It was a map, a clock, and a guide, a steady thread connecting the cycles of the heavens to the rhythm of human life. The ecliptic was the spine of the heavens, the stage where the most important celestial actors appeared. Even today, astronomers use it to map planetary positions, and astrologers place their signs along its path. When you follow the ecliptic, you are retracing humanity's first calendar, a line etched into the sky by the steady rhythm of Earth's orbit around the star that sustains us. But the stars are not perfectly still. Over thousands of years, Earth's axis wobbles like a spinning top. This slow movement is called precession, and it gradually shifts the position of the stars in our sky. Today, Polaris sits almost exactly at the North Celestial Pole, guiding travelers as the North Star. But in ancient Egypt, around 5,000 years ago, it was Thuban that held that place of honor. In another 12,000 years, Vega will shine where Polaris is now. Constellations themselves shift slowly, their outlines subtly changing as the background moves. To us, these changes are imperceptible, but across civilizations they mattered deeply, altering calendars and influencing the alignment of temples built to track the movements of the heavens. Even in their quiet, imperceptible motion, the stars remind us of time's vastness and of humanity's enduring fascination with the night sky. Precession is a reminder that even the most seemingly unchanging things are still in motion, slowly rewriting the sky above us. The night sky looked very different when dinosaurs roamed the Earth. Imagine standing on our planet 100 million years ago, while giant reptiles ruled the land. If you looked upward, the constellations we know today would not yet exist in their familiar forms. Stars drift slowly over time, and the familiar patterns of Orion, Ursa Major, and Scorpius were arranged differently back then. Some had not yet taken the shapes we recognize, while others were skewed into unfamiliar forms. The Milky Way still arched gracefully across the sky, but its details would have appeared subtly different. Our human ancestors never saw that view, but the dinosaurs did. Their world, bathed in the light of stars, long since moved. To think that the heavens have shifted so dramatically reminds us how dynamic the universe truly is. Even the constellations we see as fixed landmarks are temporary, fragile pictures in motion, slowly tracing the passage of time across the cosmos. Millions of years from now, the night sky will look strange to human eyes, just as it once did to the dinosaurs. Some stars move more swiftly than others, slowly distorting the constellations over time. Constellations are not permanent. They are illusions of perspective, shapes formed by stars at vastly different distances, lined up by chance. Over long spans, individual stars drift, gradually altering these familiar patterns. Most move so slowly we never notice, but a few streak across the background with unusual speed. Over thousands of years, these fast movers bend the outlines of constellations. Orion's belt will one day look uneven, and the Big Dipper's familiar scoop will lose its shape. These changes occur over spans longer than a lifetime, yet across millennia, the night sky transforms. Astronomers measure these motions as proper motion, subtle shifts of stars against the distant background. By mapping them, we can glimpse the appearance of future skies, or reconstruct the heavens of the distant past. The stars remind us that constellations are not eternal carvings, but fleeting alignments, momentary patterns in a universe where everything is always in motion. One star, dim and reddish, drifts faster across the sky than nearly any other. Barnard's star, quietly racing through the cosmos, a reminder of the subtle, ceaseless motion of the heavens. Barnard's star, a faint red dwarf just 6 light-years away, shifts its position noticeably even within a human lifetime. Astronomers call this proper motion, and Barnard's is the largest of all known stars. Year by year, it creeps across the sky, a restless traveler compared to its neighbors. Though invisible to the naked eye without a telescope, it has captured scientific attention for over a century. At one point, astronomers even speculated about planets orbiting it, sparking dreams of alien worlds. Those worlds proved elusive, yet fascination remains. Barnard's star is old, perhaps twice the age of the sun, and will continue drifting long after our world is gone. It reminds us that the stars we think of as fixed are not fixed at all. They wander, and some wander faster than others. Above us, satellites drift like artificial stars. If you watch carefully after twilight, you may notice a tiny point of light moving steadily across the heavens. Unlike airplanes, it makes no sound, leaves no blinking lights. It is a satellite, reflecting sunlight as it orbits Earth. Thousands now circle above us, forming a silent population of artificial stars, a subtle reminder of our presence in the cosmos. The paths of satellites are predictable, rising in the west and gliding eastward before fading into Earth's shadow. Early satellites, like Sputnik, were greeted with wonder, their faint signals inspiring both excitement and fear. Today, constellations of satellites fill the skies, aiding communication, weather forecasting, and navigation. But their growing numbers also raise concerns about crowding the heavens. For the stargazer, spotting one is still magical. To watch a satellite glide overhead is to glimpse humanity's presence in space. Small metal messengers joining the ancient lights that have shone above us for countless ages. The International Space Station often outshines everything but the moon. This laboratory, orbiting 400 kilometers above Earth, catches sunlight on its vast solar panels, glowing so brilliantly it can rival Venus. To the naked eye, it appears as a fast-moving star, sliding across the horizon in just a few minutes. For those who know when and where to look, it is a thrilling sight, a reminder that people live and work up there. Circling the planet at over 27,000 kilometers per hour, watching Earth pass beneath them 16 times a day. The International Space Station itself is a symbol of cooperation, built by nations working together. Each time it crosses overhead, it connects the vastness of the sky with the human story, a bright reminder of our fragile presence in space. Some satellites do more than simply glide. They flare. When sunlight reflects off their surfaces at just the right angle, they flash brilliantly, outshining nearly every object in the night sky. The old Iridium satellites, with their flat antenna panels, were famous for this, producing dazzling bursts visible even from cities. These flares could rival Venus in brightness, startling anyone lucky enough to be watching. They lasted only seconds before fading back into the background. For astronomers, these flashes were both a nuisance and a wonder. Light pollution in one sense, but also a striking example of orbital mechanics at work. Even as satellite designs change and iridium flares fade into history, new reflections still surprise stargazers. To see a sudden spark from an artificial star is to witness the delicate interplay of sunlight, geometry, and technology, a fleeting connection linking Earth to the machinery circling above. Rockets sometimes paint glowing trails across the upper atmosphere. When they launch, their fiery engines cut through the sky, leaving luminous plumes that can stretch for hundreds of kilometers. At high altitudes, these trails expand and catch the sunlight, even when the ground below lies in shadow. The result is a spectacular vision, clouds of light twisting and spreading, shimmering with subtle rainbow hues as ice crystals scatter the rays. For those who do not expect it, the sight can be startling, resembling a supernatural phenomenon. In truth, it is human technology meeting the upper reaches of the atmosphere, where thin air and sunlight combine to create fleeting beauty. These displays are sometimes visible across entire regions, turning ordinary evenings into unforgettable experiences for anyone who happens to glance upward. They remind us that even the work of rockets, machines of fire and force, can leave moments of wonder written gently across the sky. The night sky has grown busier with human-made lights in orbit. For most of history, the heavens belonged only to nature. Stars, planets, comets, and meteors were the only moving lights. But in just a few decades, humans have added thousands of their own, joining the timeless dance of the cosmos with quiet, metallic companions. Satellites, space stations, and fragments of debris now circle our planet, many catching sunlight as they pass overhead. To the naked eye, they appear as moving stars, crossing paths with constellations, streaking across long exposure photographs of the night sky. For astronomers, this growing swarm can pose challenges, interfering with observations and leaving trails across images of the universe. Yet for ordinary sky watchers, the sight can be strangely comforting, proof that Earth has reached into space, leaving its own quiet signature among the timeless stars. Each artificial light is a reminder of our species' ambition, of how quickly we have filled even the quietest corners of the heavens with traces of ourselves. The Hubble Space Telescope has revealed breathtaking vistas of the deep cosmos. Launched in 1990, it has shown us the universe like never before. Orbiting high above the blur of Earth's atmosphere, Hubble captures images with clarity no ground-based telescope could match. Its views of galaxies, nebulae, and star clusters have become iconic, filling books and screens with unimaginable colors and delicate detail. The pillars of creation, the Sombrero Galaxy, and countless glowing clouds of starbirth have entered our imagination because of Hubble. Beyond beauty, it provides crucial science, measuring the age of the universe, tracking the expansion of space, and uncovering the secrets of distant worlds. For more than 3 decades, the Hubble Space Telescope has circled Earth, offering a window into the vast depths of time and space. Each of its images is a gentle reminder that the universe is not an abstract concept, but a place of immense beauty, waiting patiently to be discovered. Every patch of darkness in the sky hides a multitude of galaxies. If you find a corner of night that looks empty and stare into it, you might expect nothing more than blackness. Yet, when astronomers turn powerful telescopes towards such regions, they uncover something astonishing. Within what seems to be blank space are thousands of galaxies, each containing billions of stars. Every tiny speck of light captured is an entire island universe, unimaginably far away. The realization is humbling. The emptiest corners of the sky are anything but empty. They teem with galaxies stacked across time, their light traveling for billions of years before it ever reaches us. Whenever we gaze into darkness, we are not staring into a void, but into abundance. The night's quiet spaces hold more worlds than we can fathom, hiding richness behind what seems like emptiness. Emptiness, it turns out, is an illusion. The Hubble Deep Field uncovered thousands of galaxies in a patch of space no larger than a grain of sand. In 1995, astronomers pointed Hubble at a tiny corner of sky, so small it appeared utterly empty. For 10 days, the telescope stared into that darkness, gathering faint glimmers of light. The result was extraordinary. Nearly 3,000 galaxies appeared in that minuscule view. Later, even deeper observations revealed tens of thousands more. To grasp the scale, hold a grain of sand at arm's length. That tiny area is about the size of the Hubble Deep Field. If so many galaxies exist in such a small fraction of sky, then the cosmos must contain hundreds of billions. Each galaxy holds billions of stars, each with the potential for worlds, perhaps even life. That single experiment transformed astronomy, proving the universe is richer and more crowded than anyone had dared to imagine. It showed that the most ordinary patch of black sky hides unimaginable abundance. Time itself flows differently across the cosmos. Einstein revealed that time is not universal. It bends and stretches under the influence of gravity and motion. A clock near a massive star ticks more slowly than one far away. A traveler moving close to the speed of light experiences time at a different pace than someone standing still. This means the universe does not share a single rhythm, but countless rhythms, gently woven together, a cosmic dance of light, matter, and time itself. Extreme cases, near black holes, time slows dramatically, almost to a halt from the perspective of an outside observer. Even astronauts in orbit experience tiny differences from us on Earth, their clocks ticking slightly faster or slower depending on altitude. Time is not fixed, it is elastic, pliable, a part of the cosmos itself. The stars above remind us of this strange truth. Every star in the night sky is a glimpse into the past. When you look up, you are not seeing them as they are now. Light takes time to travel, and even the closest star beyond the sun is more than 4 years away. Many stars are hundreds, thousands, even tens of thousands of years distant. That means their light began its journey long before the moment you see it, carrying a story from the past. Some of the stars you admire may already be gone, their fuel spent, their brilliance extinguished, yet their final light is still making its way toward Earth. To gaze upward is to look back in time, seeing the heavens not as they are, but as they once were. The night sky is a cosmic archive, each star a page of history written in light, reaching us only after unimaginable journeys across the gulfs of space. Some are so distant that their light began traveling long before humans existed, from an age when Earth itself had not yet taken shape. There are stars and galaxies so far away, their light has traveled for millions of years, long before humans first walked the Earth, connecting us to a universe vast, ancient, and ever unfolding. When you see the stars, you are gazing into epochs when our planet was ruled by dinosaurs, or even into ages before mammals had evolved. The photons that strike your eyes tonight set out on their journey long before humanity appeared, long before there were forests, oceans, or flowering plants. Some of that light began its trek in a universe unimaginably young, when galaxies were only beginning to form. To look at such distant objects is to step outside human history entirely, into a timeline written in starlight and distance. The stars become more than ornaments of the night. They are messengers of deep time, telling stories older than humanity itself, stretching far beyond the span of life on Earth. Even fainter, even older, is the cosmic microwave background, a gentle afterglow of creation. In every direction, faint radiation fills the sky, invisible to our eyes, but detectable with instruments tuned to the whispers of the cosmos. Nearly 14 billion years ago, the universe was hot, dense, and filled with light that could not escape the thick plasma. As the cosmos expanded and cooled, that light finally streamed free, filling all of space. What remains today is a faint echo, cooled to just a few degrees above absolute zero, but still present everywhere. A quiet reminder of the birth of everything we see, and the endless story the universe continues to tell. First discovered accidentally in the 1960s, the cosmic microwave background has since become one of the most important clues to our origins. Tiny fluctuations in this afterglow show where galaxies would one day form. To study it is to peer into the universe's infancy, when the first light escaped into darkness, and creation's earliest memory was written across the sky. Though invisible to our eyes, it permeates all of space. The cosmic microwave background is not confined to one corner of the heavens. It fills the universe completely. No matter where you point an antenna tuned to the right frequencies, the signal is there, faint, steady, and ancient. In fact, a small fraction of the static once seen on old television sets came from this background radiation. Whispers of the universe's birth, arriving quietly in every home. Though invisible, its presence is undeniable. It tells us that the cosmos was once unimaginably hot and uniform, before expanding into the vast, varied place we inhabit today. To know that every patch of space carries this same signature is humbling. It means that no matter where you stand, on Earth or anywhere in the universe, you are bathed in the same relic glow. The quiet memory of creation, still lingering all around us. The heavens once held the first galaxies forming at cosmic dawn. Billions of years ago, when the universe was young, clouds of hydrogen and helium began to collapse under gravity, igniting the earliest stars. These stars were massive, bright and short-lived, living fast and dying in brilliant explosions. Their death scattered heavier elements across the cosmos, seeding the raw material for planets and eventually, for life. The first galaxies were small and chaotic, unlike the great spirals and ellipticals we see today. Yet they were pioneers, stitching light into darkness. Astronomers call this period the cosmic dawn, the time when the universe first began to glow with starlight. To see them now, we must peer across immense distances, catching the faint glimmers of light that have traveled for over 13 billion years. They remind us that everything we see today, every star, every world, every living being, traces its origin back to that dawn. Today, the James Webb Space Telescope peers back toward that cosmic dawn. Launched in 2021, it is designed to look farther into the past than any telescope before it. With its massive gold-coated mirror and instruments sensitive to infrared light, it detects the faint glow of galaxies that formed only a few 100 million years after the Big Bang, offering us a glimpse of the universe's earliest light and a quiet connection to the beginning of everything. Already, the James Webb Space Telescope has revealed galaxies brighter and more massive than astronomers expected so early in cosmic history, challenging our understanding of how the universe grew. Its images show newborn stars wrapped in clouds of dust, planets orbiting distant suns, and light stretched into red by the gentle expansion of space. Webb peers into epochs we could only imagine before, bringing us closer to the cosmic dawn when the first galaxies sparked. Each discovery whispers that the universe still holds surprises, waiting to be uncovered in the faint light traveling billions of years to reach us. Even closer to home, some stars orbit the Milky Way's center at dizzying speeds. At the heart of our galaxy lies a supermassive black hole, a silent, invisible anchor around which everything revolves. Most stars circle the galactic center leisurely, taking hundreds of millions of years to complete one orbit. But closer in, the pace becomes astonishing. Some stars, called SC stars, whip around the black hole at thousands of kilometers per second, completing an orbit in just a handful of years. From Earth, these stars appear as faint pinpricks of light, yet their frantic motion tells volumes about the immense gravity at the galaxy's heart. Even the quiet night above is filled with hidden speed, a secret dance of cosmic forces invisible to the naked eye. Every so often, a star experiences an extraordinary fate. Caught in a close encounter with the black hole, it may be flung outward like a stone from a celestial slingshot. These are hypervelocity stars, racing through the Milky Way at millions of kilometers per hour, fast enough that one day they may escape the galaxy entirely. Even in the calm of night, the universe moves with astonishing energy, reminding us that the heavens are alive with motion, and that every quiet spark of starlight hides stories of immense power and endless journeys. To the naked eye, these stars are indistinguishable from ordinary points of light, but careful measurements reveal their extraordinary velocities. They are cosmic fugitives, torn from their homes by gravity's invisible sling, each carrying a quiet story of turmoil, of near brushes with destruction. To think of entire suns wandering alone into the endless dark is humbling, drifting silently, never to return to the galaxy that once birthed them. And not only stars wander. Some planets too roam without a sun. Rogue planets, lonely worlds adrift through the galaxy, silent, cold, and invisible to ordinary eyes. They may carry thick atmospheres or hidden oceans beneath frozen surfaces, kept warm only by their own internal energy, or the slow decay of radioactive elements deep inside. If life could exist there, it would live in eternal night, forever hidden from starlight, a secret tucked away in the darkness. Astronomers detect these silent wanderers through subtle clues, watching for faint bending of light from more distant stars, as if the universe itself were whispering their presence. These exiled worlds remind us that not all planets belong to familiar systems. Some drift alone, unseen, across the vast cosmic void. Even the seemingly empty heavens are not always clear. Vast clouds of interstellar dust float between the stars, tiny grains smaller than smoke, drifting in great silent formations. They obscure entire regions from view, hiding secrets in shadow, reminding us that the night sky is more than it seems. A tapestry of light and darkness, of visible beauty and hidden mystery. These clouds of dust and gas can obscure entire clusters of stars, turning rich regions of the Milky Way into mysterious dark patches. To ancient observers, they looked like holes in the sky, places where stars were absent. But we now know they are cradles of creation, nurseries where new stars are born from collapsing clouds of gas. Within them, gravity pulls material together, until tiny sparks ignite into newborn suns. Though dust hides their brilliance, it also protects these fragile beginnings from the harshness of radiation. These clouds are paradoxical. They conceal and they create, hiding stars even as they give rise to them. Through infrared and radio light, astronomers can peer inside, revealing hidden structures invisible to human eyes. The darkness between the stars, it turns out, is full of life and becoming, a quiet workshop of creation. Infrared light slips through the dust to show newborn suns, cradled in cocoons of cosmic material. It reveals swirling disks where planets may be forming, tiny solar systems taking shape around infant stars. Missions like the Spitzer Space Telescope and the James Webb Space Telescope have transformed our view, turning opaque shadows into vibrant landscapes. Where the naked eye sees only blackness, infrared shows clusters of young suns, filaments of gas and galaxies veiled by their own dust. It is as if we are lifting a curtain on the universe, revealing the hidden brilliance beneath the darkness. Even the emptiest-looking regions are alive with light, waiting for the right kind of vision to bring them into sight. And far beyond, across billions of light years, radio waves from quasars travel toward us. Some of the universe's most powerful signals come not from nearby stars, but from these extraordinary objects, brilliant active galaxies with supermassive black holes at their centers, sending whispers of cosmic energy across the vast darkness. As matter spirals into these black holes, it heats to unimaginable temperatures, blasting radiation across the spectrum, with radio waves stretching across the void. These quasars are so distant that their light began its journey when the universe was young, only a fraction of its current age. They are lighthouses from the deep past, their steady emissions cutting across time and space, whispers from a cosmos still in its adolescence. Radio telescopes on Earth capture these faint echoes, transforming whispers into knowledge, revealing the growth of galaxies and the hidden dance of black holes. To listen to a quasar is to hear the earliest chapters of creation, voices carried forward across billions of years. Some quasars blaze brighter than entire galaxies combined. Though born of destruction, they are anything but dark, illuminating the cosmos with unfathomable energy. Matter falling inward is heated to millions of degrees, and some quasars emit colossal jets of particles, stretching millions of light-years across the void. To the eye, they seem like faint stars. Yet behind each pinprick of light is a furnace greater than entire galaxies. Quasars are cosmic paradoxes, destruction and creation entwined, violence and beauty bound together. They illuminate the distant universe, marking galaxies in the act of forming, their ancient light arriving at our eyes as a record of cosmic power. And then there are gamma-ray bursts, brilliant flashes that shine for mere moments, yet outshine everything else in the universe. In their fleeting glow, we glimpse the rawest, most explosive forces of creation, reminding us that even in the vast calm of space, the universe can roar in brilliance. Among the most violent events known are gamma-ray bursts, brief, dazzling explosions releasing more energy in seconds than our sun will emit over its entire lifetime. They erupt when massive stars collapse into black holes, or when neutron stars collide, sending shockwaves racing through space. For a fleeting instant, their light overwhelms the combined brilliance of every star in the observable universe. Most last only seconds, some mere milliseconds, before fading into afterglows, whispering across X-rays and radio waves. Their photons may have begun their journey billions of years ago, yet they still reach us today, a flash of cosmic ferocity bridging unimaginable distances. Though invisible to our eyes, gamma-ray bursts are caught by satellites, alerting astronomers to their brief, extraordinary presence. To witness them, even indirectly, is to confront the raw extremes of the cosmos, explosions that briefly eclipse creation itself, then vanish back into silence. The night sky is alive with signals across the spectrum. Our eyes perceive only a narrow slice, visible light, but the universe hums with whispers and roars across every frequency. Radio waves flow from distant quasars. Microwaves echo the birth of the cosmos. Infrared glows from veiled dust clouds. Ultraviolet streams from hot newborn stars. X-rays blaze from black holes. Gamma rays flare from cataclysms. Each band reveals a different layer of the same grand story. The quiet sky is a symphony, invisible and immense, every wavelength a note in the vast cosmic chord. Astronomers craft instruments attuned to these frequencies, peeling back the layers of the universe to glimpse the full majesty of creation. To see only the light our eyes can capture is to hear but a single note of a symphony that stretches across space, time, and the very fabric of reality. Hear the quiet hum of the universe all around you. Feel the pulse of light that has traveled for eons to reach your eyes. Imagine the photons brushing past your skin, each one carrying a story from a star long gone, a galaxy forming, a world igniting, a black hole stirring. The night is alive with motion. Satellites glide silently overhead, tracing human ambition against the backdrop of eternity. Auroras ripple like living curtains, painting the heavens with green and violet, while comets sweep through like ancient messengers, their tails a fleeting signature of time itself. The Milky Way stretches above, a river of light carved by billions of suns, each a furnace of creation, each a witness to cosmic history. Farther still, galaxies shimmer faintly, light from billions of years ago reaching across the void, reminding you of the vastness that surrounds every breath you take. Beneath this canopy, let yourself dissolve into wonder. Your heartbeat becomes a quiet rhythm in the larger pulse of the cosmos. Your thoughts drift like dust clouds forming stars, and your presence, small yet conscious, becomes a part of the universe observing itself. As you lie there, remember, the sky above is not distant or separate. It is a living archive of time, a record of forces older than mountains and oceans, older than life itself. Every blink of light, every shimmer, every shadow is a story, waiting for someone to see it, to feel it, to wonder. So breathe deeply, let the night enfold you, and know that in this moment, beneath the infinite sprawl of stars, you are connected to everything that has ever been, everything that ever will be, and everything that exists in the silent, radiant now. Beautiful. This is a perfect, gentle closing. It carries the listener from cosmic wonder into deep calm, blending imagery, rhythm, and reassurance. The phrasing drift into sleep, into stillness, into the vast and timeless silence where stars, themselves keep watch is especially evocative, giving a sense of both intimacy and grandeur.